This skill is use algebra and arithmetic. The learning goal for this skill is to look at how algebra can be used to deal with arithmetic problems and vice versa. The success criteria is to extend and apply the laws and properties of arithmetic to algebraic terms and expressions. There's quite a few examples that I've taken from this essential assessment skill because there's quite a few skills that have not been introduced prior to this skill. Because of this, there will be effectively 11 examples that we'll be going through. For the first example here, the question is saying, which is a like term for the following? And we have this, what's called an expression here, TS. Now to some students, they will just see this as two letters put together. But in the math term, this just means T times S, or S times T. Now we don't know what T and S are. We know that eventually there will be numbers used in some type of context, but for now we'll just take them as letters being multiplied with each other. Now it's asking for a like term. A like term just means that out of these four choices here, we have to see if we can find anything, regardless of whether there is a number in front of it or not, that looks the same or involves the same letters. In this case here, T of R can't be a like term because there's no R within here. Again, R of S can't be a like term, there's no R. Now S is involved with this here, but there's no T to accompany it. So this can't be the solution. So ST is the like term because ST just means S times T. Now, even if there was a number in front of it, this makes no difference. ST is TS's like term. And we're going to find a like term for this following expression here. So again, all we need to look for is anything that involves a C and an A being multiplied together, regardless of whether there's a number in front of it or not. Now we can see here that there is an AC, which is the same as CA, and because there's no number in front, it doesn't necessarily matter. We know that this could be the like term. Effectively, it is the like term, but let's just double check. This one can't be it because there's a B involved and there's no B there. This one can't be it because yes, there is an A and a C, but there's also this little squared number that's been applied to the C. And what AC squared just means is A times C again. That's what that little 2 indicates to the C, that the C is being multiplied twice. A times C is different to C times A, or 6 times C times A. So it can't be this one. And again, it can't be this one. Well, firstly, A is being squared and there's no C involved. So this one here has to be our like term. So like terms are quite simple once you just know the foundation rules. We'll do it again for this last one. We have a 9y squared x. Now let's just forget about the 9 and let's look at the y squared x. Y squared x just means y times y. It's twice because of the number 2, and then times x again. So we have to look for something that involves a y squared and an x. It doesn't matter of the positionings of it, and it doesn't matter if there's a number in the front of it as well. X squared can't be this, that's by itself. Y x squared, it can't be this one because there's 2 lots of x's and 1 lot of y, but look, we're looking for 2 lots of y's and 1 lot of x, so it can't be this one. Xy, well, it can't be that one because we need another y. So here we have x, there's one x, check. 2 y's with the y squared, check. And regardless of whether there's a number in the front or not, does not matter. This is our like term. This question here, we're looking for the option that shows this expression here simplified correctly. Here we have x plus x plus x plus x. This is the same as just getting 4 lots of x's, isn't it? Regardless of what the letter is, how many there are here when added together will dictate the multiplication, because multiplication is just repeated addition. So it's not x divided by 4, it's not 4 plus x, and it's not x to the power of 4, because x to the power of 4 means x times x times x times x 4 times. We're just adding them together, and there are 4 lots of them. So this must be the answer. You're just collecting how many x's there are, and it's being multiplied. And this also happens in the subtraction phase, but now we've got something going on here. We've got 9b, and we're taking away 3b. Now let's just look at the number component. Let's just look at 9 take away 6. We know 9 take away 3, rather. That should be 9 take away 3. 9 take away 3 is 6. So we know that our answer has to involve a 6. Right? But what it's saying is there's 9 lots of this b, because it's 9 times b, and we're taking 3 of them away. We should be left with 6 lots of b, or 6 times b. So it can't be that one, can't be that one, can't be that one. It has to be this one. And the reason why we can do this is because this right here is our like terms. We have like terms within these 2 terms because they're the same letter is involved, and regardless of what the number is. If this said 9b take away 3bt, we can't necessarily do this subtraction because these 2 are not like terms because of this t that's been introduced. So the only way that we can do this, including the addition, is to make sure that these terms are like terms in order for them to do the subtraction or addition. Simplify the expression. This also goes with terms that have powers in it. We know that 6 take away 2 is 4, so we're going to have a 4. And the x squared, because they're like terms, they are just what remain. So it's 4x squared. So don't get intimidated by the letters, because the letters are just there to tell you whether you can, if they're like terms, and tells you if the expression remains there or not. We just care about the arithmetic part, the addition or subtraction, and we will get into multiplication and division in the next set of examples. So right here, we have a question, which answer shows the expression simplified correctly? So instead of it being added, like in the previous example, it's being multiplied. And remember, when a term, specifically like terms, are being multiplied, it's going to be a to the power of whatever number of a's there are being multiplied. In this case, there are 5. So this would be a to the power of 5. It is not a all put together. So that's, well, technically it is if you were going to write it in this type of notation, but this is not the correct notation. 5a just means 5 lots of a, which is a plus a plus a plus a plus a. So it can't be that one. This has to be a solution, and again, it's not 5 plus a. Which option shows this expression simplified correctly? Now we can see that all of them are being multiplied together, and we've got a combination of numbers and 2 sets of letters. We should just break this down to 2 different parts, getting the numbers collected together. So we have a 7 and we have a 2. What is 7 times 2? This is 14. So that's the number component done. If there was another number being multiplied as well, you would also multiply that accordingly. If it was plus, you would just leave this alone. You just make sure that you multiply the relevant numbers that are in the whole expression. Next, we see how many x's there are. There's an x here and an x here. And because there are 2 of them, it's x squared. They're being multiplied together, so it's x squared. And then we just have this y tagging along. And so here is our simplified version. Can't be this one, can't be this one, can't be this one. 14x squared y is our answer here. Now, if you, for some reason, and this is fine, if you get the answer 14yx squared, that still suffices as a correct answer as well. Even though the y and the x squared and the x squared y, they are the same, they are technically the same, just the positionings have been swapped around. So that will suffice as an answer as well if you get that, because these 2 are the same thing. Which option shows the expression simplified correctly? Now this one can be considered a bit of a tricky one because we have this fraction line, which is a division. First we want to see the number component to it. So let's split this up into two parts. 3 over 12. You can use your calculator for this, but because it's a simple fraction, 3 over 12, what number can go into both 3 and 12 that's considered the highest common factor? In this case, 3 can go into both 3 and into 12. 3 goes into 3 once, and 3 goes into 12 4. So we have 1/4. Now we're just looking for terms that have a 1/4 in it, or something over 4. We've got this one, can't be this one because it has 12 over 3, can't be this one because it has 3 over 12, and this one also has a 4. Now we just have to figure out if it's b to the power 3 or b to the power 5, and this is determined by whatever is here. So this is b to the power 4 over b. When you see a b by itself, see if you can get into the habit of writing it as b to the power 1, because technically it means the same thing. This just means there is one b being multiplied by itself, which is just b. It's not b times b. If it was b times b, it would be a 2, but in this case, it's just a 1. Whenever you see a term that looks like this, you subtract the powers from each other. Or in other words, we figure out what 4 minus 1 is, which is 3, and that becomes the new power, b to the power 3. So it can't be this one. This will be our answer here. Now this type of maths gets into year 9 and year 10 index laws maths. If this is a bit tricky to understand, that is fine. As long as you can understand the breakdown between the number and the letter section, you should be fine. For this question, we're going to fill in the missing term in this simplified expression. So what this is saying is we have x plus y plus some unknown expression will give us 2x plus 3y. Now we can see that there is this 2x already here, and x plus x is 2 lots of x. So this component with the x's is fine. We need to figure out what y plus some question mark, which we don't know, will give us 3y. So we have one lot of y, and we have to add a certain amount of y's to get 3y. Well, in this case, this has to be 2y, because 1y plus 2y gives me 3y, and that's where that 3y tags along. So in order to complete this, you would just add 2y. The last question or example here is fill in the missing term in the simplified expression. Now this one is the last question. It is a bit tricky. This has to do with division. And again, we're going to break it up into two parts. We're going to break it up into the number part and the term or the letter part. So this is saying 16 divided by some number will give me 8. Well, that's simple. 16 divided by 2 gives me 8. So we know that the number part to it has to be 2. Now we have this y squared divided by some number gives me y. Well, in this case, y squared, remember how in the previous example, if there is a division, you take away the powers, and here there's a power of 1. 2 take away 1 gives me 1. Well, 2 take away 1 gives me 1. So this has to be y to the power of 1 in order for this to work. So here we'll put 2y1. Now, obviously you can't put the power, you will just leave it as 2y. So 16y squared divided by 2y will give me 8y. And that is it for this skill. Go ahead and attempt it, and I'll see you in the next and final video. Bye-bye.